Let's talk about piecewise functions. So a piecewise function is a function that uses more than one equation to describe its behavior. So here's an example of what a piecewise function looks like. Here are the components of it. You have the name of the function, just like any other function. You have this giant curly brace, and that's telling you that there are multiple pieces to this piecewise function. It's telling you that it is a piecewise function. For the x values, -2 to -1, the value of the function is -2. Between -1 and 0, the value is -1. Between 0 and 1, the value is 0. Between 1 and 2, the value is 1. So depending on what x value you're looking to evaluate for, you're using a different piece of this function. So let's do this example. Here we have this piecewise function. It's defined on the interval -2 to 2. We're asked to find f of -1, f of -0.75, and f of 1. So going for f of 1, -1, this is saying that we're looking at the value of the function when x is equal to -1. Now there are two portions where we see -1 here. So this is -2 to -1. This is -1 to 0. This portion is only used up until -1, but it doesn't include -1. And we know it doesn't include -1 because this isn't or equal to, right? This is just a strict inequality. Right here, x is greater than or equal to -1 means that for -1, we use this portion of the function. So f of -1, we use this piece here because x is equal to -1. That piece is just -1. There's no x to plug in at all. This is a step function. But there's nothing to plug in. It's just the answer is -1. For -0.75, this right here is between 0 and -1. -0.75 is between -1 and 0. It fits into this portion right here. So we're looking at these x values, and then we're looking for the corresponding part of the function. So f of -0.75, let's see, look at this row right here, -1. It's purple. For f of 1, there's two portions of this piecewise function that have 1. This one is between 0 and 1, but it doesn't include 1. There's no underline on this inequality, so it doesn't include the value 1, the x value 1. Here, x is equal to 1, greater than or equal to 1. So we would use this portion to find f of 1. So f of 1, looking at this piece right here, is 1. So basically, you would be using any of these different portions based upon the x value that you see inside of the function notation. Let's do some more. These are all just evaluating. That's what we're doing. For f of -2, this is our function. We have 3 different pieces. If we have x equal to -2, that means that we need to use this portion right here, because this portion includes when x is equal to -2. So we want to use the second piece. So we're taking -2 and we're plugging it into this second piece right here. That second piece is -x plus 1 quantity squared plus 3. So taking -2 and plugging it in, we have -2. Maybe I should do that in red. -2 because we're plugging in -2. -2 plus 1 squared plus 3. Simplifying, we have -1 squared plus 3. Let's see. This will be -1 plus 3. That's 2. So f of -2 is 2. Oh, boop, boop, boop. All right. For f of 0, for f of 0, 0, the x value 0 falls between -2 and 1. So we're going to use the second piece again. So we have -0 plus 1, quantity squared plus 3. This will come out to be -1 plus 3. This is 2. F of 0 is equal to 2. For f of 5, 5 is greater than 1. So the x value 5 is greater than 1, and that means that I'm using this last portion down here. So using that third piece, we have 1/4 times 5, because that's x. Okay, we're using this portion right here. Oh gosh, it's lagging on the screen, isn't it? Oh well, we're using this portion. Plus 2. So that'll be 5/4 plus 2. 13/4, I hope. Yeah, that should be right. So f of 5 is 13/4. So really, don't overthink these. You're looking at the x value. You're seeing where that x value lies based upon the different ways that it's been broken up. And then you just plug in the value. It's really like, imagine a number line. Imagine these are my x values. And we have -2 and 1, and those are the different places where where this function breaks up. It's like if you're less than -2, so I can do like an open circle here. If you're less than -2, you're using this part of the function. If your x value is less than -2. If your x value is between -2 and including -2, so let me do a solid blue dot there, and 1 excluding 1, you would use that blue portion of the function. And then down here, if your x is greater than or equal to 1, so I'll do a solid dot to denote that, you would use this portion. So when I'm looking at 0, or when I was looking at -2, if I look at this little graph I've made, -2 is blue. which means that I'm using that blue portion there. And that was because it was included. All right, let's do more. Is that my last example? I think this is my last example here. Pause the video, by the way, if you want to try this one out for yourself. This one's a little bit interesting, right? It uses a little bit of a different notation. We're going to find h of 0. Now, it says that we should use 1/4 x squared minus 4 if x is not equal to 2, and 4 if x is equal to 2. 0 is not equal to 2. It's just, they're not the same number, right? So we want to use this one because x is not 2. So we have 1/4 times 0 squared minus 4. That's just going to be negative 4. H of 0 is negative 4. For h of 2, this is a little different because look, x is 2. That means that we should use the second piece. The second piece, just there's no plugging in a value. It's just the number 4. H of 2 is equal to 4. That's the second piece. Bam. Finally, h of 4, this is going to be just like the first one. 0 is not 2, 4 is not 2. So we're using the first piece. Because I'm lazy. 4 is not equal to 2. So use the first piece. So we have 1/4 4 squared minus 4. That's going to turn into 0 if you do the math on it. You're going to have 16 divided by 4, which is 4. 4 minus 4 is 0. So h of 4 is equal to 0. So practice some problems, practice the piecewise function problems, evaluating. It's not bad. The hard ones really are going to be things like this, where you have to pay very, very, very close attention to which ones are less than or equal to, and which ones are strictly less than, right? So maybe just one last thing. If I look at all the places this breaks up, -2, -1, 0, 1, and 2, 2 is not in the domain. F of -1 we already did, F of 1 we already did, but let's look at F of -2 really quick. For -2, we're looking, where is x equal to -2? That would be right here. -2 less than or equal to x. So you would use that first piece, which is just equal to -2. For f of 0, you would use this piece right here because x is equal to 0. So f of 0 would be 0. Anyway, I'm just rambling now. That's evaluating piecewise functions. You'll be fine. Give it some practice. I'll see you in another video. Bye.